Alright, so today we're diving into the world of carboxylic acids and their derivatives. Carboxylic acids are some of the most reactive functional groups in organic chemistry, and understanding their behavior and nomenclature is crucial for mastering organic reactions. In this video, we'll cover the basics of carboxylic acids, esters, amides, and anhydrides. By the end, you'll have a solid grasp of how to name these compounds and understand their key properties. Let's get started. Carboxylic acids are organic compounds that contain both a carbonyl group, which is a carbon double bonded to oxygen, and a hydroxyl group, which is an oxygen bonded to hydrogen, on the same carbon atom. This makes them terminal functional groups, much like aldehydes. Carboxylic acids are among the most oxidized functional groups you'll encounter on the MCAT, with 3 bonds to oxygen. Only carbon dioxide, with 4 bonds to oxygen, represents a more oxidized form of carbon. Because of their high oxidation state, carboxylic acids are the highest priority functional groups in organic chemistry nomenclature. They take precedence in naming over other groups. Carboxylic acids are named by replacing the E at the end of the parent alkane name with the suffix OIC acid. However, you should also be familiar with their common names. For example, methanoic acid is commonly known as formic acid, ethanoic acid as acetic acid, and propanoic acid as propionic acid. Carboxylic acid derivatives are compounds derived from carboxylic acids, but with their hydroxyl group replaced by another substituent. The main derivatives you need to know are esters, amides, and anhydrides. Esters are formed when the hydroxyl group of a carboxylic acid is replaced with an alkoxy group, which is an OR, where R is a hydrocarbon chain. Esters are named using 2 terms. First, the alkyl group from the alcohol that contributes the OR group, and second, the parent acid with the suffix -oat replacing OIC acid. For example, if methanoic acid is combined with butanol, it forms butyl methanoate. In this naming system, butyl describes the alkyl group attached to the oxygen, and methanoate refers to the parent carboxylic acid. Next we have amides, where the hydroxyl group of a carboxylic acid is replaced by an amino group, which contains nitrogen. Amides can vary in complexity depending on whether the nitrogen is bonded to hydrogen atoms or additional alkyl groups. Amides are named similarly to esters, but with the suffix amide replacing OIC acid. If there are substituents attached to the nitrogen, they are labeled with a capital N to indicate their attachment to the nitrogen atom. For instance, N-ethyl N-methylbutanamide indicates an amide with both an ethyl and a methyl group attached to the nitrogen. Finally, we have anhydrides, which are formed by the removal of water from 2 carboxylic acid molecules. Anhydrides can be cyclic or acyclic, depending on whether they form a ring structure. Anhydrides are named by replacing the word acid in the parent carboxylic acid name with anhydride. If the anhydride is formed from 2 different carboxylic acids, both are named in alphabetical order before adding anhydride. For example, ethanoic anhydride is derived from 2 molecules of ethanoic acid, while propanoic anhydride comes from 2 molecules of propanoic acid. So there you have it, a detailed overview of carboxylic acids and their derivatives. Understanding these functional groups and their naming conventions is crucial for anyone studying organic chemistry. Whether you're dealing with simple carboxylic acids or more complex derivatives like esters, amides, and anhydrides, being able to recognize and name these compounds correctly will help you navigate through many chemistry problems. If you found this video helpful, please give it a thumbs up, share it with your friends, and subscribe for more chemistry insights. And if you're using the King of the Curve app or web app, make sure to like and comment on what topics you'd like us to cover next. Check out the app for more detailed content and quizzes to test your knowledge. Thank you for watching, and good luck studying.